In this video, we're going to take a look at TransparentMeta from a high-level perspective and see how it works and what are the designing principles that we followed in order to implement it so that you get a high-level understanding of what TransparentMeta is and what you can do with it. Cool. Before we get there though, I want to talk about different output transparency techniques that we can use in order to comply with AI transparency law. One obviously is metadata, but then we have watermarking where we take transparency metadata information and some of them we can inject directly in the zeros and ones of an audio file. We also have AI identification. That's an AI classifier that can take as input an audio file and tell you, yeah, this was generated by an AI, or no, it was just human generated. And you can also have fingerprinting. So it's a bunch of different techniques and each of them comes with pros and cons. But in the case of TransparentMeta, you guess it, we deal with metadata. At Transparent Audio, we're thinking also of building products that deal with other techniques, but for TransparentMeta, we only deal with a metadata. So what's TransparentMeta? In its essence, TransparentMeta is a Python library, it's an SDK, to write, read and verify transparency metadata in audio files. These are some of the designing principles that we've used to implement TransparentMeta. First, we want it to be compliant with AI transparency law all over the world so that you don't have to understand all the legislation. As long as you use TransparentMeta, you're fine. Then TransparentMeta is open source. At Transparent Audio, we are huge proponents of open source, and that's also true for us as co-founders and individuals. And so we'll try to open source as many of the products that we are going to build. Also, we want for TransparentMeta to be as easy as possible to use, and indeed its SDK, as you'll see in subsequent videos, is very simple to use and to integrate in your workflow. And finally, TransparentMeta is secure, meaning that we use cryptographic signing in order to make it as trustworthy as possible. Okay, in terms of open source license, we use the GPL v3. These are some of the features that you have in TransparentMeta. Of course, you can write transparency metadata and you can read and verify the transparency metadata that you've written in a file. All of this happens, the verification happens through cryptographic signing that makes the whole process of retrieving metadata trustworthy. And we have also some utility functions in terms of cryptography in order to create and handle key pairs that you would use for then cryptographically signing your transparency metadata. Now, what are the problems that TransparentMeta solve? Well, the main one obviously is it allows you to be compliant with AI transparency law all over the world. So at the level of metadata, because of course there are different levels, as we said, there are different techniques, and so in certain legislation it's important to have multiple levels in order to be as robust as possible. But as long as we're dealing with metadata, you are safe because you are compliant. Then the other aspect that's very important to us is that you're going to have secure metadata, because the metadata that you'll read from the files that you've written with TransparentMeta are going to be super trustworthy, and we'll see why that's the case in a while. And finally, we also deal with attribution. What's attribution? Well, this is something really big in the music industry, especially these days with AI. So in order to create a song, there may be an artist who wrote the lyrics, and then there may be another one who performs the bass, and then perhaps there's an AI that did the whole drum arranging and what have you. Now, what's important in order to distribute royalties in a fair way is to know who did what and what did what, and by what I mean what AI did and whether AI has been used or not. So you can bundle all of that information in our transparency metadata using TransparentMeta. We'll see that once again in a second. Who should use TransparentMeta? Well, any company that deals with AI-generated audio, especially voice AI companies that deal with text-to-speech models, voice cloning or speech synthesis, but also generative music companies, or even companies that deal with voice and music data, not necessarily AI-generated, because at the end of the day, they can provide a lot of transparency information that's always really useful. How does TransparentMeta work? Well, at a very high level, there are mainly three steps. First, you generate private and public key pairs for cryptographically signing and verifying the metadata that you write in the audio files. Once you have that and you handle those keys, the next step is to write and assign the metadata, and then you can actually do the opposite, and that is reading and verifying the metadata. Now let's jump into point number 2 and point number 3 into more detail. So we'll start with writing. We have an MP3 file. Let's say like this is something that we generated with a text-to-speech model, so it's AI-generated speech. So what we want to do here is to provide transparency metadata information. We can write that with TransparentMeta, and then we use our private key for cryptographically signing the metadata. So now we have the bundled metadata along with the signature that we sort of like got through signing with our private key, all of this like bundled in the MP3 file itself. So we're good to go. Now, where do we store this information? Where is metadata and where is the signature stored? Well, it's stored in a tag that's called ID3 version 2. That's a tag that's native to MP3s, but we use something similar also for WAV files. So we bundle all of that information into an ID3v2 tag. Cool. We are talking about transparency metadata, but what do we mean about that? Well, we have a quite stringent definition of that, but that's still like quite minimal. So it's the minimal information that you have to provide in order to be compliant. What is that? Well, you have to pass the name of your company, the company that's generating the audio file, the model, the name or the version of the model, the timestamp, the AI usage level. We have a bunch of AI usage levels, like for example, fully AI generated or AI assisted, the content ID, the user ID, and the private key ID, so that it's going to be possible to retrieve the associated public key at reading and verification time. Just be aware here, we're not talking about the private key itself, but the associated ID that we can use as a reference when we want to retrieve the associated public key. Finally, we have an optional field called additional info. So here you can put whatever you want. It's a simple Python dictionary. So feel free to put whatever you want in here, but we highly suggest to have in this field attribution. So here, as you can see from this example, you can put like information about like the lyricist. So in this case, John Doe, the composer Jane Smith, and if there's an AI which did production, you can put the name like of that AI, the model, whatever that is. So then when it's time to basically share the royalties across like all the different people or machines, companies who have a say, then there's like that necessary information. So that's how we bundle attribution information directly in the transparency metadata. Now let's move on to the opposite use case, that is reading. So we've written our file, so we have our file with cryptographically signed transparency metadata, and now we need to read the information and check whether it's valid or not. So how do we do that? Well, again, we use TransparentMeta to extract the metadata and the signature. Now we take our public key and we use our public key to check whether or not the signature is valid. And if everything like checks out, then we extract the metadata and we are sure that this is the original metadata and there hasn't been any modification. But there may be a case where even just like a single letter, like within the metadata, the signature has been altered for whatever reason. It could be like a malevolent actor or just like by random chance, okay? In that case, the verification process with the public key will fail, will throw an error, and then at that point we know that the metadata is no longer reliable, right? So how do we do that? Well, through cryptographic signing that ensures that we can trust the result of the reading. Because if something has gone wrong with the metadata, the signature, we can realize that and know that the metadata has been tampered with. So we don't know like how it's been tampered with, the modification that it had, but we know that something went wrong. So this is why TransparentMeta is highly secure. That's it for the introduction at a high level of TransparentMeta. In the next few videos, you'll see how to get started and how simple it is to implement all of these use cases that you've seen here.